Hello, folks, and welcome to task 1.2 in our fraction unit. We're going to remind ourselves how to add, subtract, and multiply fractions. So, we are going to talk about mixed numbers, improper fractions. If you thought fifth grade was the end of it, sorry, folks. We continue forth with fractions. So, let's look at our first question. What's a mixed number? So, mixed meaning different things. The mixed number here in question is 3.5. Because there's a whole number and a fraction, we need to turn it into an improper fraction that is just the numerator and the denominator. So, we're going to use a picture. We're going to use Kit Kats because they're really helpful at breaking apart. So we know we have to find groups of 2, the 1/2. So I'm going to circle my groups of 2. Here we go. Here we go. And I'm going to notice that I have 1, 2, 3, 4, 5, 6, 7 groups of 2. So 3 over 2 would, 3.5 would turn into 7 over 2. We can also show that by knowing that 3 and 1/2, we multiply the 3 and the 2. That gives us 6. And then we have 1 left over. So that would be 7 over 2. So the picture, the model, describes exactly what's happening in the algorithm, the math that you're used to seeing. All right, so now let's look at which fraction is larger. How do you figure that out? Ooh. So what I want you to do is pause the video, figure it out, and enter your answer into formatives. All right, folks, so you find the lowest common multiple. Remember I said they weren't going away, which is 35. You then find the factor for both the denominator and the numerator, and you come out with 6/7 is bigger because it is 30 over 5. 30 over 35. Got myself there. All right, so now the algorithm or the steps to add and subtract fractions are listed here. I am not going to go over these steps. They are there for you to, I'm not going to read these steps. We are going to go over how to do this problem. So our example is going to be 2 1/4, 2 1/4 minus 3/6. So how in the world do we do this? Well, first we have to convert that 2 1/4 to an improper fraction. So remember, this means 2 times 4 plus 1. So the 2 times 4 is 8 plus 1 would give you 9. We do nothing to that bottom number. We just carry it over. So now we have 9/4 minus 3/6. Ooh, we have different numbers on the bottom. So now we have to convert those into the exact same number so that we can just do the subtraction on the top. Now, we need to, again, find the LCM. You could use 24. That would work. However, that's not the LCM here. Spoiler alert, the LCM is actually 12, which is a smaller number, easier to work with. So I'm going to use 12 on both of these. And then 4 times 3 is 12. So you have to do 9 times 3, which would be 27. And then 6 times 2 is 12. So 2 times 3 is 6. So, oh, look, now we have 27 minus 6, which will give us 21 over 12. Or we can simplify that down into 7 over 4 because we know that 21 and 12 have factors in common. So the greatest common factor would be 3 here. So we are simplifying that fraction down into 7 over 4, and then we take it and we turn it back into a mixed fraction. That is 1 3/4, because 7 minus 4 is 3. We have 3 left over. All right, folks. So now let's get into what does it look like to use a model, to use a picture to represent these fractions, because we are now going to multiply two different fractions. So the algorithm is the math, the step-by-step, here's how I do it. The model, geometric area picture, is showing the same thing, but we are drawing it out, okay? So the first thing you need to do when you are using a model here is we need to separate this box into three parts. So we have one here and two here. This is our 1/3, okay? And since we have one of those, we are going to shade in one of the thirds. Again, this isn't perfect. Your model doesn't need to be perfect. Now, we need to account for our 3/4 over here. So we're going to divide this box into 4 equal pieces, and we are going to shade 1, 2, 3 of them. All right, folks, so I have added to this picture. Don't panic. So now we know we have 12 boxes here. We have 12 different places. We are looking for the parts that overlap. You can see 1, 2, 3 boxes have both the denominator and the numerator in them. So that is our answer. Then we are going to simplify with the LCM, least common multiple, which is 3, because, 3, to 1/4. Now, this is the model, the picture. We can confirm this by using our steps for multiplication. So when we multiply, we just go straight across the top, straight across the bottom. So 1 times 3 is 3. Let me get my pen back. 3 times 4 is 12. We do the exact same simplification. We get 1/4. So the picture shows us why the algorithm, why the math, I'm going to put this here because you're going to hear algorithm and model. The picture, the model, shows why the algorithm, the math, works. So make sure that you are writing down examples of vocabulary. I'm here if you have questions. Happy solving.